Now let us understand the types of sets. Okay, what are the types? So there are basically 4 types. Okay, my first type is null set. Null set, or sometimes we call it empty set. Okay, the name is clear. Empty means what? There is nothing in that set. So we denote this set as either in some books just like this, and in some books it is like this, right? So this means what? That nothing in the set. There is nothing in the set. Any example? So we can write example as negative natural numbers. If you want to write about negative natural number, there is no negative natural number. Natural number starts with what? 1. So there is no negative sign behind the natural number. So we can call it null set. Okay. So you can look at other examples also in your book. Now second is singleton set. Again, as the name suggests, singleton set. Let's check the spelling. I think it is like this. Okay. Singleton set means that it has only one element, single element, right? So again, what is the example of singleton sets? You can write number which is neither prime nor composite. Number which is neither prime nor composite. So what is my number? This number is 1. 1 is neither prime nor composite. So there is only one element. So we can call it singleton set, right? Or you can say, if you want to write days of a week starting with letter M. So only Monday is there. So this is my singleton set. Okay. Another example is even prime number. Only 2 is there. So this is also a singleton set. So singleton set means what? That you have only one element in that set. Only one thing. Then third, finite set. Of course, what is the meaning of finite? Finite means something which we can count. Okay. So finite is what? More than one. It will be more than one, but definitely we can count it. Like days of the week 7, months in the year 12. Okay, we can count it, but it is more than one. If one is there, then it is called a singleton set. But if more than one, and if we can count it, then it is finite set. And last form is a set. Of course, it will be more than one, but we cannot count it. For example, set of natural numbers. It starts with 1, 2, 3, 4, 5, 6, 7, 8, and it will go till infinity. We cannot count it. Set of whole numbers, set of integers, everything. So anything which we cannot count is known as infinite set. Sets of stars, right? But sets of planets, of course, we know, right? Our sets of planet in the solar system. So we know this is finite set. So these are the types of sets. Okay, null set, no elements. Singleton, one element. Finite, more than one, and we can count. Infinite, more than one, of course we cannot count. Okay. So next is no, two sets. Suppose A and B. There are two sets. Okay, we are talking about equal sets. We are talking about equal sets. Two sets can be equal. We can write A equals to B, but there is a condition. Condition is that all the elements of A should also be in B. and all the elements of B should also be in A. Let us take an example. Suppose A is what? 1, 2, 3, and B is what? Then these two sets are called as equal sets. Why? Because here also 1, 2, 3 is there, here also 1, 2, 3 is there. If you change anything, then it will not be equal. Suppose if we write, right now, all the elements of A are in B also, 1, 2, 3, 1, 2, 3 here. But in B we have one extra element which is 4. It is not there in A. So we cannot call these two sets as equal sets. So understand the concept. First thing is what? All the elements of A should be in B. Second, all the elements of B should be in A. Right? Now we have a mathematical notation for this. Okay, how do we write this first statement? We write it as that A like this. What is the meaning of this? This meaning that all the elements of A is also an element of B. Okay, and for this we write all the elements of B are also elements of A. So remember this sign. Okay, this is what you can make a U, a horizontal U, and then putting another line there. Correct? So this means A is all the elements of A are also element of B, all the elements of B are also element of A. If these two things are there, then only we can write that A is equal to what? B. Correct? If there is a change in anything like this, we cannot say A is equal to B. Now suppose if all the elements of A is not included in B also, then we can write like this. Okay, similarly here also. Okay, understand? Two sets, equal sets. Okay, let us understand equal sets with one example. Okay, here I have taken three sets, A, B and C. Now we need to find whether these three sets are equal with each other or not, or if any two of them are equal or not. So my first set is X such that 3x minus 1 is equal to what? 2. Okay, so here there is an equation, 3x minus 1 is equal to 2. If you solve this equation, this 1 will go there and then it will go in division and we will get, so we have got value of x as 1. Correct? So for A we can write, let us write for A there is only one value that we are getting as 1. Okay. Now B, what is B? B is such that x such that x belongs to natural number. Okay, so it will start with 1 and x is neither prime nor composite. So there is only one number which is not prime and which is not composite. Again we have got B as 1. Similarly for C you can say x such that x belongs to natural number, again starts with 1 and x is less than 2, it is not even 2, again only 1. So since all the elements of A, B and C are equal to each other, so we can write that these three sets are equal sets.